It's nice to see you all. Hello, everyone. I'm Catherine Spunknavel. I'm Senior Associate Dean of Faculty. And truth be told, I have goosebumps right now. I am so thrilled to see all of you in person. It's been a long, difficult couple years, and my hat's off to each and every one of you for all your contributions to the college, to the students, to each other, sustaining each other through these really tough times. So thank you so much for coming tonight. We're in a really wonderful window of what we hope is so safe gathering at the moment. And I look forward to this evening's events. So before we get going, I'd like to take a moment to thank our Dean's Awards Review Committee. This was a dedicated group of folks who helped us review applications from the chairs and spent a great deal of time deliberating and deciding who we were recommending for the dean to choose and select this second year's Dean's Faculty Awards. So thank you very much, each and every one of you. I'd also like to thank the chairs. You folks are all incredibly busy individuals managing your basic science and clinical departments. Nonetheless, more than a dozen of you took the time to put your faculty forward for consideration for these awards. And that means so much to myself and certainly to the dean and the review committee to be able to look at these extraordinary individuals in consideration for the awards. A night like tonight does not happen without the support and dedication of a terrific support staff. So I personally want to thank Barbara Donadio, Lenore Carpinelli for their help in putting together and organizing tonight's events. And certainly Mike Cotter and his team, they've all gotten PhDs, I think, in how to run Zoom meetings. And now we're venturing into Zoom hybrid meetings as well. Tonight's event is being recorded. And we also have several participants online tonight, participating online. So we're thrilled to have our virtual participants as well. So now I'd like to take a moment to recognize our dean. Dean Nadler has been with us for a few short years. He has helped sustain us through these very challenging times of COVID. His leadership and sensitivity towards the staff, the faculty, has just been tremendous. This awards ceremony, the criteria, the whole idea of this was his brainchild. And we launched this, you may remember, virtually last year. It was 100% virtual. And we're so thrilled to have Dean Nadler tonight in person. And thank you very much, Dr. Nadler, for allowing us to have this Dean's Award ceremony. And please, I open the mic for a few words. Thank you.
Well, thank you. Please, no applause for me. You should all applaud yourselves for everything. And it's so wonderful, as said, to have this event. We have so few events in person these days, and we hope there'll be many more. So it's so nice to have all of you, our distinguished chairs, faculty, staff, and guests here, deans and administration for this second annual event, the first one in person, hopefully many more after this. As Catherine mentioned, it takes a team. I guess in New York, you call it a town or a village. It's everything's different in Virginia, or a county or a city to make this happen. And many people have helped, especially starting with the committee. And I only played a small part in getting this started. Each year, it's a little bit different and hopefully improved because we learn, or I learn, there's so many things that our faculty are doing that need to be recognized. And sometimes in our first time we do it, we miss out on a few people. We've added a few more categories this year, and I'm looking forward to additional categories even next year. And I don't think anyone will object if we have more categories and more people to recognize, since it's so important. There are so many missions that we strive to accomplish, and as Catherine mentioned, we're in the midst and maybe coming out. We don't know if there's another variant of a pandemic, and that's adding to all the stresses we have without that. And then also, as you know, from the School of Medicine, we're undergoing a major curriculum revision. We have an LCME visit, and some faculty are taking advantage of opportunities to retire. And that offers some opportunities and challenges, some opportunities to recruit some new faculty. And we actually have recruited some wonderful new basic science faculty, but also offers challenges to meet all the missions. So there's increasing stress. And as many of you have read about or feel yourselves, there's increased stress, there's increased burnout, and there's lack of job satisfaction. There are a lot of articles that have been written about this in academic medicine, a lot of people that are in the clinic and hospitals, all the stresses. And there's actually a wonderful article I'd recommend people reading in Academic Medicine 2018 that actually looked at this in a very important way about vitality. Faculty vitality is one area. If you can improve faculty vitality, you can improve morale, well-being, and reduce burnout. And one of the ways we're adding a little bit of that is this evening's event, recognizing the faculty that are really performing the key missions that we have here at New York Medical College in such a wonderful way. And just a reflection, just look back at some of the positive things. We just completed the largest match event in New York Medical College history, and it was a wonderful match in terms of the programs. We tied the record in the nation for largest number of students matching in urology. Internal medicine was still #1. So I know if Susan Rackland's usually around, and she says, well, radiology was there too. Pediatrics was right up there as well for those pediatricians. But one of the ways we can improve morale and reduce burnout is recognizing the good things that we do. And we don't do that enough, to be honest with you. We don't do that enough. We always deal, when we open up our emails, we have the problems, we have the issues to solve, but just recognizing and saying thank you. So this is a small way that the dean and dean's office, faculty affairs office can say thank you to those people we recognize this year. And for those people that didn't win this year or didn't recognize this year, we'll get to you. Don't worry, keep at it, and we'll recognize you. There's a lot of wonderful chairs that support their faculty. So those are the short remarks I want to have, because we want to hear from the award winners and have time for a nice socialization. I believe Dr. Halpern, our Chancellor and CEO, now has a message recorded that he wants to share with everyone. So thank you.
Good afternoon, everyone. I'm sorry I cannot join you in person. Perhaps when one of the members of the faculty figures out, like Star Trek, how to beam us to various places or to split us in two, I could have solved the problem for this afternoon. But we've got the faculty awards program at 4 o'clock, but I'm also supposed to be in Manhattan at the program at the Lander College for Women with Senator Lieberman and his wife at 5:15, and I couldn't figure out with the timing for driving and finding a parking place how to be two places at once. So I'm forced, therefore, to offer you my greetings by video. I want to congratulate all the faculty award winners, and I want to join you in celebrating the achievements of the faculty. People mistakenly sometimes refer to faculty as staff. The faculty are not staff, they are the college. That's what a college is. It is a community of scholars that in our case exists for the generation and conservation and dissemination of knowledge about the causes, prevention, and treatment of human disease and disability. It's who we are, it's what we do. And I am thrilled to celebrate your achievements with you, congratulate the award winners. And I hope everyone has a good program while I'm sitting in traffic on the Henry Hudson, crawling my way into Manhattan this afternoon. Have a good program, everyone, and congratulations to the award winners.
So thank you. And now without further ado, we'd like to first start the ceremony by recognizing the slate of nominees that were selected for honorable recognition. We had far more candidates to review than we had awards to hand out this year. So these honorable recognitions are equally well-deserved and certainly high honors. As I call your name, I'd ask that you please come forward to accept your certificate from Dean Nadler. So first we recognize Dr. Erjement Deriche. If you could please come on down. We know it's there. Oh.
That side, all right, we'll do it that side. Okay.
Okay, very good. Thank you. Thank you. Next, please, Dr. Abbas Smiley. Congratulations. Next, please, Dr. Garrett Weber. Congratulations. For the remaining three individuals, we have Dr. Rosa Martinez Rosenberg, who is participating virtually. Dr. Rosenberg, congratulations to you. Two additional recipients, Dr. Sang-Mi Chung and Dr. Alan Dozier, who are not attending tonight. I'm not sure if they're on virtually, but congratulations to the both of you as well. So we'll begin the Dean's Awards with the presentation of the Rising Star Award. This is a terrific award that recognizes our junior faculty members, one from the basic sciences and one from clinical sciences, who excel in an area related to teaching, research, or institutional service. This year's Rising Star Award in Basic Sciences is Dr. Victor Garcia from the Department of Pharmacology. Dr. Garcia earned his PhD in pharmacology in 2015. After completing a fellowship at Yale, we got him back as an assistant professor. He's been remarkably accomplished since then, doing work in molecular biology and pharmacotherapeutics related to the cardiovascular system. He's immersed himself in the college community. He's involved in many teaching endeavors as well as service. Most recently, he's participating in the junior recruit basic sciences, and we're tremendously happy and pleased to have him winning this award this year and among us as a faculty member. The next award goes to the Rising Star in Clinical Sciences. This year's recipient is Dr. Supriya Jane. Since Dr. Jane became faculty in 2011, she's built a national reputation in the field of pediatric cardiac MRI. She's developed a clinical research program utilizing MRI as an imaging tool and taken lead roles in major international organizations related to her interest. She's accomplished with many publications and has led a national multicenter study of myocarditis in children following COVID. And for her leadership and teaching skills, Dr. Jane was recently appointed as clinical education liaison at NYMC and serves on the School of Medicine's Curriculum Redesign Task Force. Dr. Jane is recognized as an outstanding mentor for both students and residents. Congratulations, Dr. Jane.
Thank you. Thank you so much. Yeah, we were asked to say a few words, so I would definitely use this opportunity to thank all the people. So thank you very much, Dr. Nadler, to the review committee, to especially to Dr. Newman for nominating me, and for all the other folks for supporting the nomination, especially Dr. Winson, Dr. Goetz, Dr. Kessler, and Dr. Amler. I do want to take this opportunity, as I said, I had this time, I wanted to thank my parents who've been great sources of inspiration to me, my mom who's been in 40 years of experience in higher education, and I think my love for education and research stems from her. And I think I've always learned from her about working with dignity, dedication, honesty, and integrity, and building relationships. And from my dad, who died suddenly in 2006, but always said, live your life to the fullest, work for the moment, don't worry about the past or the future. And then finally, my biggest pillars of support, my husband Parantap, my two beautiful kids, hopefully watching, my 7-year-old Anushka and 10-year-old Arjun. So without them, I can't do all the things I'm doing. My 7-year-old always asks me, Mom, I always thought you were a doctor, but then when I'm doing research or I'm presenting or I'm teaching, and she's so confused, but I always tell them, being a physician, that's the most beautiful thing, because not only are you a clinician seeing patients, but then if you have the passion, you find answers, you do research, you teach. And so I couldn't be happier. So thank you for recognizing all the efforts. Thank you.
Dr. Garcia, would you like to say a few words?
Yeah, so sorry, I was not prepared. But as a junior faculty, we succeed and we prosper based off a lot of different levels of support, right? We have support from administration, who that has been fantastic so far. For me, we have support from our mentors, and they come at all different levels, right? We have the chair of the department, who's fantastic, Dr. Schwartzman, who's been my mentor since I was a PhD student here at New York Medical College, to people and current faculty members who now also basically serves as my mentors as well. They have tons of experience. They have tons of insights that I don't have. And they've helped me along the way. And I'm forever grateful to the committee, to my mentors, to everyone for giving me this award. It's a special honor and I'm really grateful. Thank you.
Okay. The next award category is for excellence in research. This award recognizes a basic science and a clinical science faculty member who are emerging or established in their research field as leaders. These individuals surpass performance requirements for their positions with distinction and merit. They have evidence of significant high quality scholarship as evidenced by acknowledged by their peers, and they certainly contribute to the advancement of research in their departments and at the institution. This year, recipient for Excellence in Research Award in the Basic Sciences is Dr. Sachin Gupta from the Department of Pharmacology. During his more than a decade at NYMC, Dr. Gupta has demonstrated sustained excellence in a multitude of research programs that he developed. During the height of the pandemic, Dr. Gupta rapidly adjusted to a complex task of running a lab and maintaining an innovative translational research program, notably adding a supplement to his parent RO1 to study whether novel steroid molecules reduce COVID infection. His tenure at NYMC is represented not only by his productivity, but also by his ability to attract collaborators, both from within and outside the college, in support of his significant research related to pulmonary hypertension. Dr. Gupta is a role model for students who seek to engage in research and has successfully mentored students who have gone on to successful careers. At NYMC, he serves on several committees, including the PhD program director for pharmacology, the graduate school steering committee, PhD admissions, and the strategic planning committee. Congratulations, Dr. Gupta.
Thank you very much. Honorable Dean, Dr. Nadler, Spunknavel, friends, colleagues, and students. Good evening. I'm honored to be here today and truly humbled to receive this Dean's Research Excellence Award. I feel privileged that my decades of long contribution to science has been recognized by the Faculty Award Committee, by Dr. Spunknavel, Dr. Nadler, and New York Medical College. My journey as a scientist started when my father passed away, an untimely demise of his. His loss embedded within me the thrust to seek answers and remedies for cardiovascular diseases. I was blessed to have very good mentors while I was pursuing my PhD, MD PhD in Japan, notably or especially Dr. Okada and Uchi, who inculcated in me the culture for dedication and perseverance. And that was the foundation of my career as a future scientist. I also would like to take this opportunity to thank Dr. Wolin at New York Medical College for giving me the opportunity to develop and think like a mature scientist. I believe that science is a teamwork, and I have been fortunate to have worked with many distinguished collaborators during my scientific career, and would like to acknowledge Dr. Miano at the University of Augusta and Dr. Lanier from Westchester Medical Center for their very productive collaborations. And of course, as we all know, that students and fellows are pillars of your lab. And I would like to give them a shout if they are there online with pride to all of them, that their contribution and for their accomplishment as well. It is a common knowledge that one's working environment plays a monumental role in their success. And I'm fortunate to have a very encouraging and exemplary chair, Dr. Schwartzman. I hope, Mickey, you're there. I would like to express my heartfelt gratitude to you for nominating me for the Dean's Award and for your relentlessly supporting me in all my endeavors. I also want to thank your great team, Gail, Jennifer, and Olga, although she has retired, and Eileen, for putting up with me and going out of their way to help me. Without you guys, we couldn't send any grants out or do any kind of budgeting. I would be handicapped, totally handicapped. And of course, it is irrefutable that behind every successful man, there's a great woman. And I would sincerely like to thank my better half, Rakhi, whose brilliant ideas and insights have helped me to build a very strong and a successful research program. I hope I will continue my work, and I'll keep encouraging younger generations of scientists to pursue science as well as pursue the passion for science. Many more years to come, and I hope I will have much more fruitful collaborations in the future. Thank you all for coming and tuning in to make this occasion a memorable one. Thank you.
Next up, we have the Excellence in Research Award for the Clinical Sciences. This year, we had not one, but two extremely well-deserved recipients. Our first recipient is Dr. Fawaz Al-Mufti from the Department of Neurology. Since Dr. Al-Mufti joined the faculty of NYMC in 2000 in the departments of neurology, neurosurgery, and radiology, he's a triple threat. He has contributed substantially to the research reputation and mentorship of learners and of the institution. Under his leadership, the Neuroscience Summer Research Program has grown with the successful mentorship of over 30 students, residents, and fellows this past year, leading to more than 100 peer-reviewed publications and a multitude of national abstracts, platform presentations, and book chapters. Truly impressive. His own research focus on the pathophysiology and clinical outcomes of subarachnoid hemorrhage, acute ischemic stroke, and the evolving field of neuroendovascular surgery has produced a massive scholarly productivity in team science, resulting in over 200 contributions to the literature. And his works are highly cited and have been showing to be positively impacting patient care. For his ability to inspire and successfully mentor leaders in the clinical setting, Dr. Al-Mufti was recently named the Assistant Dean for GME Research for NYMC, where he'll be contributing to the development of GME research across the colleges in the School of Medicine's clinical affiliate training programs. So with that, congratulations, Dr. Al-Mufti.
Well, thank you so much, everyone, for being here. It's an absolute honor. I'm sorry. Did I do that? This is such an important and such an important and monumentous occasion in my life. It's an even greater honor to be in such a distinguished ranks of the current and past honorees of this amazing award. Everyone here has made such incredible contributions to science, and I'm truly honored and humbled to be amongst your ranks. If we're able to see farther, it's because we stood on the shoulders of giants. And I'd like to seize this opportunity to recognize the main sources of inspiration in my life. I'd like to thank Dean Nadler, Dean Spunknavel, Dr. Milligan, Dr. Milletien, who's with us today, and the Dean Faculty Awards Review Committee for this honorable award. To my mentor and friend, Dr. Chirag Gandhi, thank you for your compassion, your mentorship, your dedication to your team. You've definitely inspired and motivated me to become a better physician and scientist. To my parents, I'd like to thank them immensely. Thank you for always having faith in me and for teaching me humility, grit, and always to persevere. To my students, I would not be here without my students. To my students for always challenging me and forging me into an eternal student of medicine. The future is bright because of all of you. Lastly, but by no means least, to my dearest wife, who's with us today as well, Rola, my children, Jude, Jenna, Adam, and Jane, for the unconditional love, support, and encouragement. You have been my rock and my lifeline, and all that I am and or hope to be, I owe to you all. Thank you very much.
Our second recipient for the Excellence in Research Award in Clinical Sciences this year is Dr. Cara Grimes of the Obstetrics and Gynecology Department. Dr. Grimes came to NYMC in 2018, initially as faculty in the departments of OBGYN, and later also joined the Department of Urology. She's a regional and national leader in her field, whose contributions in clinical practice and research have positively impacted gynecological care. She has served as a research mentor to students, residents, and faculty within and outside her own departments. In 2020, she became the first associate chair of research in the Department of OBGYN. Since then, she has transformed the research culture of the department, resulting in a more than 300% increase in the scholarly activities, presentations, manuscripts, and national presentations of faculty and students. She's been instrumental in engaging over 25 students in research projects that have yielded an impressive number of active projects, presentations, and published manuscripts. According to her chair, Dr. Sean Tegerardi, Dr. Grimes is a superb, unrivaled, enormously impactful, and exemplary faculty member whose example of research excellence should be a model for NYMC. Congratulations, Dr. Grimes.
Thank you very much. I'm honored to receive this. And I always tell the students that research is a team sport. So there's definitely lots of people to thank, and I'm not going to be able to list them all. Dr. Al-Mufti, we need to meet. You're one of my idols. And if I can build a program that's as good as yours, I will do my best. I'm honored to share this podium with you. I also want to thank Dr. Nadler and Dr. Tegerardi for really giving me the time and the support to do what I love to do. I get to work with medical students and residents and faculty, not only doing my research, but doing the research that they want to do. I just came back from a conference this week where two of our MS2s, one presented at the podium and another one presented a poster. And it was just so wonderful to see all the attendees coming up and talking to them and engaging with their research. It's very, very exciting. And I just want to thank all the medical students, residents, and faculty I've done wonderful projects with. And then I'm going to embarrass Judy, but Judy, just wave or stand up. She's our research coordinator, and I invited her to attend today because that's how we get things done. Thank you very much.
We'll now present the next category of awards, which is the Excellence in Teaching Award. This award recognizes a basic science and a clinical science faculty member who excels in their work by consistently performing beyond expectations in teaching and the education of our learners. These individuals surpass performance requirements for their position with distinction and merit and provide outstanding service to the School of Medicine community. This year's recipient of the Excellence in Teaching Award in Basic Sciences goes to Dr. Patrick Lento. Since joining NYMC in 2012, Dr. Lento has served as an outstanding educator, guide, and role model for NYMC students. From the beginning of his career, Dr. Lento has been passionate about teaching and mentoring, both at the undergraduate and graduate levels. In his role as course director for the second-year pathophysiology course, he has worked to encourage and involve other faculty to elevate standards of teaching and has been an active member as well on various committees at the college in reviewing, monitoring, and upgrading academic courses and curricula. Recently, he led a task force to review and refine educational needs of students with disabilities. Since 2014, he has been an annual recipient of the Student Award for Excellence in Teaching and Mentoring at the college, truly impressive, and has received outstanding preclinical faculty awards on multiple occasions. Most recently, he was selected to serve as a Phase 1 director for what will be the newly redesigned MD curriculum. Dr. Lento, congratulations.
Thank you very much for the opportunity to address the group. Thank you, Dr. Nadler, Dr. Spunknavel, the selection committee, and importantly, my chair, Dr. Islam, the chair who recruited me here, Dr. Fallon, who's no longer with us, and all those who supported, I guess, my nomination for this particular award, including Dr. Kessler, Dr. Moshman, and others. It has been my personal feeling that teaching is its own reward. And the fruits of our labors really are or result from match day and our residency graduates. It is truly an honor to be recognized by my peers for an award such as this, and I am honored and humbled to be in a group, as Dr. Al-Mufti mentioned earlier. I would say that I would like to dedicate this award to all my past and present teachers. Who I am as a teacher is really a reflection of those individuals. And while the list is really too long to enumerate, I would like to single out one particular person here at New York Medical College, someone who's no longer with us, Dr. Steve Marks. Steve, for those of you who knew him, was the consummate teacher, at least in my opinion. He exuded enthusiasm and was a marvelous teacher. He was respected by his peers, but more so by the students. He himself was a student of medicine, and I'd like to see myself in his shadow as a student of medicine. Importantly, as we move forward with the hope and aspiration for a new curriculum that can transform our medical school for our medical students. Because after all, that's why we're here. Thank you very much.
Thank you, Dr. Lento. We'll now present the Excellence in Teaching Award for the Clinical Sciences. This year's recipient is Dr. Wilbert Farano from the Department of Medicine. Dr. Farano, during the course of his decades-long career, he's dedicated himself to academic medicine and to the mentoring of young physicians. As Director of Research for the Cardiology Division at NYMC and Westchester Medical Center, he's mentored literally hundreds of medical students, residents, fellows, and junior faculty, which have resulted in over 1,000 peer-reviewed publications. Dr. Farano has the distinction of at least one PubMed cited publication for each and every fellow he has worked with in his career, in addition to publications with more than 600 other trainees and medical students. Many of Dr. Farano's mentees have gone on to successful academic careers, both in medicine and in cardiology. Dr. Farano's commitment to teaching is reflected in his receipt of countless teaching awards. The division director of Westchester, Dr. Julio Panza, wrote of Dr. Farano that he is the epitome of academic cardiology who has enjoyed a tremendously prolific career based largely on his unparalleled ability to stimulate intellectual curiosity and the desire to reach academic heights in young physicians. Dr. Farano, please come forward to accept your award. Congratulations.
Thank you very much. The American Society for Clinical Pharmacology and Therapeutics interviewed me for the June issue of their journal, Clinical Pharmacology and Therapeutics. I'd like to read the last 3 sentences from the page proof that will be published in June. I keep focused and motivated because I enjoy training physicians to be excellent physicians, teachers, and researchers. Nothing is more enjoyable than seeing my trainees flourish in whatever they do. The professional accomplishment I am most proud of is that I have mentored more than 1,000 cardiology fellows, N equal 266, other trainees, N equal 633, and numerous junior faculty for papers that are listed on PubMed. One of the medical students graduating this year, Chan Kim, is first author of 6 papers that are listed on PubMed. Thank you all very much.
Okay, the next award category is for excellence in mentoring. This award recognizes a basic science and a clinical science faculty member who excels in their work by consistently performing beyond expectations and mentoring students, residents, faculty, and fellows. These individuals show exceptional commitment to mentoring and advising that promotes professional development and ultimately the success of their mentees and advisees. This year's recipient for Excellence in Mentoring Award in the Basic Sciences goes to Dr. Mary Petsky, the Department of Pathology, Microbiology, and Immunology. During her tenure at NYMC, which began in 2005, Dr. Petsky's teaching has encompassed all 3 schools of the college and recently expanded to others within the Touro College and University system. She has consistently received high evaluations from the students that give her top ranking among the lecturers. Dr. Petsky also serves as Assistant Dean for Medical Student Research and Program Coordinator of Biomedical Research Concentration in the School of Medicine. In these mentoring roles, she has overseen the research activities of over 850 students across all classes in the School of Medicine. She also serves as faculty advisor to the Student Senate Research Committee, the Medical Student Research Forum e-board, and the Medical Student Research Seminar Series. Dr. Petsky is passionate about promoting academic growth and works tirelessly to support the development of the next generation of medical professionals and scientists. We're so fortunate to have you here, Dr. Petsky. Congratulations.
Thank you, everyone. I'm honored. I would first like to begin with acknowledging Dean Nadler for initiating this wonderful mechanism for recognizing faculty achievement. I would also like to recognize Dr. Catherine Spunknavel and the entire Faculty Review Committee for the hard work that you've put in. I would like to thank the chairman of my department, Dr. Islam, for nominating me, for two other colleagues who wrote me letters of recommendation, and for the many others who have supported me. So what is a mentor? If you go online, you'll find many definitions. The one that I like comes from the University of California, San Diego. It reads, a mentor is a seasoned, experienced advisor who provides guidance, advice, feedback, and support to the mentee, serving variously as role model, teacher, counselor, advisor, sponsor, advocate, and ally. It's quite a bit. I would add to that catalyst, because I firmly believe that it is the job of the mentor to assist their mentees in reaching their potential through identifying, developing, pursuing, and eventually achieving their goals. I have had many mentors throughout my life, too many to mention, but I would like to give particular recognition to Dr. Irish Schwartz. He is the professor emeritus and the chairman of pathology, microbiology, and immunology, recently retired. It is thanks to him that I obtained my first position at New York Medical College, and he successfully mentored me to become a productive member of the faculty. I would also like to thank Dr. Jan Galibter. Through observing him in his role as director of medical microbiology and immunology course, he showed me what it was to be a mentor and how to mentor myself. Outside the colleagues who have been so incredibly supportive, I see several here from our department. I would also like to thank first and foremost my family, my 4 children. And I think Dr. Gupta said that behind every successful man, there is a powerful woman. Well, the converse may not necessarily be true, but in my case, it is. And I have to thank my wonderful husband, Wayne, who is here. He has been my helpmeet in every sense of the word. It's been his steadfast support and his willingness to do far more than 50% of the childcare and housework that has enabled me to pursue my own goals. Thank you very much.
The next Excellence in Mentoring Award goes to a faculty member in the clinical sciences. And this year's recipient is Dr. Robin Altman from the Department of Pediatrics. During her long career as faculty at NYMC in the Department of Pediatrics since 1991, and as Chief of General Pediatrics at Westchester Medical Center since 1995, Dr. Altman has set the tone, atmosphere, and culture for the clinical areas in both inpatient and outpatient settings. Dr. Altman has been the architect of one of the most active and sought-after pediatric hospitalist programs in New York, and her personal supervision of the teaching mission has directly impacted the increase in the interest of our students in choosing pediatrics as a profession. It's not a surprise that Dr. Altman also took on a significant leadership role as program lead to implement the Department of Pediatrics Faculty Mentorship Program. This was accomplished in collaboration with the Dean's Office, and might I add you, during COVID. She helped to initiate this program now in its second year, and I can say I've personally witnessed firsthand that Dr. Altman not only talks the talk, but she walks the walk. She strives to further develop the potential of junior faculty members through formal mentorship, and she's had served as a mentor and role model to countless medical students and residents during her decades-long career. And for that, her chair, Dr. Newman, recants that this has amassed a tremendous academic legacy that we recognize today. Congratulations, Dr. Altman.
Wow, I'm a bit overwhelmed. Wish I wrote some notes down, but here goes. First, I want to congratulate all the awardees this evening. I'm honored to be in the room and share this evening with you. I want to thank Dean Nadler and the committee for this honor. It's so incredibly important, meaningful to me. And I want to especially thank Dean Nadler for recognizing and making faculty mentorship such an important part of the mission of the medical school. We all know, everyone knows here, how important mentorship for medical students and residents, those doctors at the beginning of their careers is. However, what's so easy to forget is how important mentorship is for faculty, really at all stages of our careers. And Dean Nadler made the point of bringing to us the necessary resources and national expertise for us to work with and really develop what I think is a really great program. Just as everyone has acknowledged, a program cannot be successful without support of a lot of other people. I want to also acknowledge Dr. Spunknavel and Barbara Donadio, two amazing human beings who have been my mentors for the past couple of years. We are real comrades in what we are working on and the goals that we strive for with regard to mentorship. And I have to acknowledge Mary Gianta, my division manager, who is the administrative support for our faculty mentorship program. Without Mary, the program really wouldn't exist. I invited her to be here in person this evening, and unfortunately she's sick and home, but I hope attending virtually. And so Mary, thank you. And this award is really partially yours as well. And I want to also acknowledge and thank all of the members of the faculty in my department. Oh, and of course, I thank Dr. Newman, my chairman, who nominated me, but also elevated the importance of faculty mentorship to make it a priority for the department and gave me the opportunity to lead that initiative. And to the rest of my peers, faculty who joined me in the program, over 20 members of the department who gave of their time to be mentors, really only because they wanted to do it and because of how important it is to them. And again, mentorship program couldn't be successful without that level of support. And many of you are here this evening. And so there's just one other thought that I have, which is in June, it will mark my 31st year as a member of the clinical faculty at New York Medical College and my 26th as a division chief. And I just want to share a sort of foundational opinion that I've developed over the decades, really. And that is that clinicians who choose their career path into academia are just fundamentally different than clinicians who choose a different path. We are hardwired differently. And it's in our DNA. We don't just want to take care and heal the sick. We want to make things better. And we've heard it speech after speech today, and even in the words that Doctors Nadler and Halpern and Spunknavel shared, like that is who we are. And so, you know, I think that our academic identity is so key and is a very, very important part of how we can achieve that inner goal, that inner drive. And so I really appreciate the opportunity to have participated in a small way in helping the department and the medical school accomplish that. I really look forward to continuing that work, and I really, really appreciate this honor. Thank you.
The next award category. This is a special award. And this was an award that was devised by Dean Nadler and encompasses both teaching and mentorship at a distinguished level. And this year's award, not surprisingly, goes to Dr. William Frischman, the Department of Medicine. Dr. Frischman. Dr. Frischman is professor of medicine and pharmacology at New York Medical College and chair emeritus of the Department of Medicine. He's had an extraordinary career in medicine that led him to the college in 1997. For over 50 years, he's touched the lives of patients, students, trainees, and colleagues through his work. He's an internationally recognized authority in cardiology and cardiovascular pharmacology, a journal editor, and an academic leader. A deeply respected and highly valued teacher and mentor, he's received every major teaching award at NYMC. Dr. Frischman is also the recipient of the Glaser Award by the AAMC, a leading educator in North America for his work on curriculum reform, and the Teaching Scholar Award for the American Heart Association. He's mentored scores of students, trainees, and faculty over the course of his career, and served as a counselor of the NYMC chapter of the Alpha Omega Alpha National Medical Honor Society for over 40 years, the longest tenure in AOA's 116-year history. Dr. Frischman takes enormous, well-deserved pride in the impact he's had on the careers of numerous mentees, each of whom he recalls fondly. He's provided close personal mentorship for over 600 learners and research projects, and was honored as Master of the American College of Physicians for his mentorship of student research. Many of Dr. Frischman's mentees have gone on to highly successful academic careers, including as university presidents, deans, department chairs, and section chiefs. It is likely that each of you here tonight, whether you know it or not, actually already knows someone who personally knows Dr. Frischman. Dr. Frischman, congratulations.
Thank you, Dr. Nadler, Dean Spunknavel, and the selection committee for this wonderful recognition. I also want to acknowledge my chairman, Neil Schluger, who's here tonight, for his support, and to my students, house staff, and trainees, both past and present. I also want to recognize the other awardees tonight. Dr. Arano, I've known him for 50 years. 1972, I was presenting a paper on a drug that he had worked on, and I remember him coming to my presentation. It's remarkable that we're here together during this time. I also I can attest to the great joy and satisfaction that comes from teaching and mentoring, both as a recipient and as a participant. After clinical practice, it is the obligation of physicians both to teach and to mentor, an obligation. In the classical saga, The Odyssey by Homer, the character Mentor appears for the first time. Mentor is the teacher of both Ulysses and his son Telemachus. In a professional lifetime, having a mentor makes your life's journey more manageable and less stormy, and you can make it home easier when the ship is righted. I still interact with one of my mentors, Dr. Thomas Killip, the father of the coronary care unit in the United States. He is now 95 years of age, and we still publish together. The last article was last year. He wrote the foreword in one of my books describing our lifetime relationship as mentor and mentee throughout my career. I've had the privilege of teaching at 3 medical schools and also during my years in the Army. My long experience, 25 years, has been in New York Medical College. Since 1976, I have taught many students during all 4 years of medical school and have mentored many in research, including over 20 during this current academic year. Many of my former mentees are deans, department chairs, section chiefs, and hospital CEOs. Dr. Garrick, in fact. Dr. Alan Kadish, the president of Toro, was my mentee. If you look at his CV, the first 2 papers he and I did together, his first on his CV, are with me. We published 2 major original studies on the first paper on transesophageal echocardiography in the United States with Alan and I. And he was a 4th-year student, and on cardiovascular drug management and cardiovascular surgery, important anesthesia paper. Again, I want to thank NYUMC for this recognition today, for the opportunity to take care of patients, to teach in the classroom on the wards, and to mentor students in research. To honor my family for their contributions. I want to again thank the organizational committee, Barbara, for all of the help. And I hope to continue in these pursuits during the years to come, and to rejoice in the accomplishment of my trainees and my colleagues. Thank you.
The next award category is the Excellence in Diversity, Equity, and Inclusion Award. This Dean's Award recognizes an outstanding faculty member who exemplifies the value of diversity in their scholarship and service and maintains a record of high accomplishment, leadership, and dedication in such efforts. This year's recipient of the Excellence in Diversity, Equity, and Inclusion Award is Dr. Pamela Ludmar. Since first being appointed to the faculty at NYMC in 2012, Dr. Ludmar has distinguished herself as a leader and a role model who's devoted great efforts to updating the curriculum for medical students so that it reflects and values inclusivity, respect, and justice that are so important, not only within the school, but within the profession of medicine. Dr. Ludmar is responsible for the creation of the 4th-year specialty track curriculum, coursework around interprofessional collaboration, and the new required curriculum in health sciences, system science. Although already actively engaged in the redesign of the MD program curriculum, after the tragic deaths of George Floyd and Breonna Taylor, Dr. Ludmar, with the assertion that the NYMC community needed to be more deliberate in its efforts to combat systemic racism, bias, in health inequities with action, proposed the creation of an anti-racism, anti-bias committee at NYMC. The committee, made up of a team of dedicated students, faculty, and administrators, led by Dr. Ludmar, has since created a series of short and long-term action steps for the NYMC community. Tangible outcomes have included targeted faculty development efforts, a complete review of the MD program curriculum with implementation of new programs on the identification of personal biases and the creation of the grant-funded transformative education leadership program, combating systemic racism and implicit bias through medical education. Dr. Ludmar is the recipient of the Curriculum Innovation Award from NYMC in 2013, and in 2018 was a nominee for the American Medical Women's Association Gender Equity Award. At AMWA, she has also served as Associate Program Director for the Elevate Leadership Certification Program for Women Physicians. Dr. Ludmar, congratulations.
Thank you so much for this award. First, I'd like to congratulate all the other recipients of awards. It's really an honor to be standing among so many wonderful, impressive people. I would like to thank Dr. Schluger, Chair of the Department of Medicine, Dr. Spunknavel, and the whole review committee for presenting me with this award. I really do appreciate it. Dr. Nadler, thank you too for creating such a wonderful event, but also for all of your support of the work of the Anti-Racism, Anti-Bias, and Health Inequities Steering Committee. And I really appreciate this award and value this award today on the last day of Women's History Month. So I am obviously a female physician, but I'm also a first-generation American born of immigrant parents from Latin America. So I've really experienced diversity, equity, inclusion, and belonging, both in my personal and professional life for a very long time. I would like to say that the work of the Anti-Racism, Anti-Bias, and Health Inequity Steering Committee was a massive team effort. We had wonderful and passionate people really involved, students across the curriculum. We had basic science faculty, we had clinical faculty, we had staff from all across NYMC really working together with a common goal to make NYMC School of Medicine a better, more inclusive place for everybody that would really train anti-racist physicians dedicated to improving the care of all patients and to improving the healthcare system. You heard a bit about what we did and how we got there, but really it was such a fantastic experience to bring everybody together. And I became a better person just from working with these incredible members of our own NYMC community. Some of them are here. So this award is also for you, for all of those of you who helped, would not have accomplished what we did without all of your participation, really the engagement of the entire community. Now, since today is the last day of Women's History Month, I just want to take this time to acknowledge all the women in the room. Thank you so much for all of your efforts, for everything that you do for NYMC. It is a pleasure and an honor to work with you, and I look forward to many more opportunities to do so. So thank you, everybody.
And now we'll present our final award, which is the Outstanding Achievement Award. This award is presented to a faculty member whose efforts have sustained significant achievement in combined areas of teaching, research, and institutional service. Faculty nominees must demonstrate leadership, accomplishment, and recognition in academic areas of endeavor, demonstrate outstanding reliability and cooperation. Collaborative, team-based translational work and achievements are essential criteria. They exemplify outstanding conduct and exceed expectations in the performance of duties over multiple years of service to the school. They're also well known as exemplars of the institution's core values at a superior level, continually fostering pride, professionalism, the standing of the college, and the School of Medicine. This year, this honor is bestowed on Dr. Patrick Stanton. Since joining the faculty of NYMC 17 years ago, Dr. Patrick Stanton, as a distinguished neuroscientist, has brought international recognition to NYMC from his research ranging from the basic mechanisms of neuroplasticity to translational research investigating the effect of brain trauma, both in the military and in athletics, also on neuronal structure and function. And he's also excelled in mentoring, teaching, and service to the college. He has published 111 peer-reviewed papers, 26 review articles, and many of his papers have been highly cited in the literature. Since coming to NYMC in 2004, Dr. Stanton has maintained continuous major funding from numerous sources, oversetting more than 50% of his salary from grants. An excellent teacher and mentor, it is noteworthy that Dr. Stanton has the distinction of having mentored the largest number of PhD and MD PhD students in the cell biology and anatomy department. Dr. Stanton is also deeply committed to the NYMC community. He chairs the Animal Care and Use Committee and serves on numerous other committees, including tenure, appointments, and promotions, the Admissions Committee, and was also a member of the Anti-Racism and Anti-Bias Committee. In summary, Dr. Stanton is an exemplar scientist, teacher, mentor, colleague, and wonderful member of our community, whose presence is a major strength and an inspiration to us all and to our institution. We're so very fortunate to call you a colleague, Dr. Stanton. Congratulations.
Thank you, Dean Nadler, Dr. Spunknavel. I'd like to also thank the selection committee and for this most extraordinary and most important award, being such because it represents the recognition of one's peers, one's colleagues at the school. I have to thank Dr. Ettlinger as well, my chair, for nominating me for this award, but much more importantly for recruiting me to come to New York Medical College 18 years ago now. Because this brought me to an extraordinary community of scholars, colleagues, friends who have made my experience as a researcher grow and prosper, have also contributed to my development in education and service to the college in so many ways that I might not have realized I would ever have the opportunity to do. So I also want to thank all of the many members of the college who, beyond the faculty, the support people who make sure that we're able to actually grow and develop our research programs and our educational programs and our trainees to the best extent and greatest extent that we can. Without you, it would also not be possible for any of us. Most importantly, I have to thank the members of my laboratories over the years, both when I was at Albert Einstein College of Medicine and at New York Medical College. My trainees as graduate students, as postdoctoral fellows, have taught me every bit as much and likely more than I've taught them. We've worked together as colleagues, going all the way back to my mentor, John Sarvey, who taught me very early that you're colleagues at a different career stage in your careers, but you're all colleagues working together with a love for science and a respect for the pursuit of science. So all of those people in my lab over those years, I will take the opportunity again during my talk to throw up some pictures and mention them by name. I would be remiss not to mention Dr. Shali Zhang, the Senior Research Associate, my friend and colleague and co-investigator in everything we do in the laboratory, who has been at New York Medical College, who came with me and has been as long as I've been at New York Med. He's the true linchpin of the laboratory, although there are so many linchpins over the years, you realize. I would just say this is an extraordinary honor and an extraordinary award precisely because of what you've seen that's come before me tonight. All of the other colleagues of mine who've received extraordinarily equivalent awards for their contributions to the college, for their contributions to my education, development, and environment that's been just extraordinary. So to be able to be one of the individuals participating with such an august group and to be able to share it with all of you, my colleagues and friends over the last 18 years is truly the most extraordinary part of this award. Thank you very much.
So good evening, everyone. While you're all enjoying the dinner buffet, I'd like to introduce our Outstanding Achievement Award winner, Dr. Stanton, who will be presenting Deconstructing and Reconstructing Memory. Dr. Stanton, thank you so much.
Thank you, Catherine. So I get to first block you from getting dinner and now block you from going home. So I will try to do my best to tell a little story and to end on time. And please keep eating. Don't let me in any way get in the way of that. What I'd like to do today is to give you a little bit of a sense of the arc of the research programs that I've been involved with and program that I've created over virtually all of the time of my career, which is impossible to tell you all of the things that we've worked on over those times I've had the joy of working on with tremendous numbers of colleagues. But what I would like to do is tell you a story built around the winding path of getting a drug approach to disease treatment of neuropsychiatric disorders eventually into clinical trial. And it's a very winding path and it takes a long amount of time. And I think it'll be illustrative of a number of the interests in my lab, but also how challenging and rewarding it can be to move oneself from even the mindset of a basic scientist in graduate school, doing research for the pure joy of the knowledge and discovery, to growing interest and growing efforts in the translation of this research into treatments that can actually help people. It's still an ongoing process. The drug I'm going to tell you about in this story is in clinical trials now, in phase 2 and phase 3 clinical trials. But I'm going to go back and sort of start with my interests when I got into neuroscience and into graduate school. I arrived with an interest in one of the fundamental questions, I think, for all of us, which is what makes us us? What makes our human individuality, personality, our thoughts, our ideas, and the uniqueness of them, how do those things work? That's why the first word of my title is deconstructing, how to get from this phenomenal property that we humans share with all sorts of other extraordinary organisms in the animal world, to store and recall information, which is an important and key part of who we are. And remembering who we are. I'm reminded of a book title that Jimmy Breslin had a book after he had a stroke. He said, I want to thank my brain for remembering me. So I arrived then in graduate school with this interest in learning and memory, ill-formed, thinking I would become a neurochemist. But then I learned for the first time about for how long scientists had thought about the question of how do we store memories. It really goes back at least to the early part of the 19th century, when the psychologist William James, predating knowing what neurons were and that neurons were connected by synapses, already discussed the idea that in order to store information in our minds, we must be changing and creating new patterns of connections. This eventually became the memory engram, the idea that we would have to build new connections by which elements of our minds could talk to one another in ways that would represent memories of experiences we had had. Then along came Donald Hebb in the 1940s with a little book called The Organization of Behavior, which is in print again, and I highly recommend it. It's a great read and not very long. Where as a card-carrying psychologist, he presented and pushed the pivotal concept that in order to really understand how the brain learned things and stored these memories and retrieved them, we were going to have to look inside the black box and find mechanisms by which changes occurred in the brain in response to experiences, things happening to us. And he even hypothesized a mechanism, suggested as purely a thought mechanism at this point, suggesting the so-called Hebb synapse, the idea that when an axon, the output of a neuron of cell A, is near enough to excite cell B, active enough to excite cell B, persistently and repeatedly takes part in making cell B fire its own action potentials, some growth process or set of metabolic changes would take place in one or both of the cells, such that A's efficiency as one of the cells firing B would be increased. And then if you came along and were exposed to a similar pattern of input, again, in the world right now, it would activate those stronger connections, which would recruit the other connections they were connected to, and you would now have a recreation of the pattern of activity that represented your memories connected to that experience. Or in the nutshell term that I was so fond of as a graduate student, neurons that fire together, wire together. Now, I arrived in my rotations in graduate school, just as they do here at New York Medical College, with rotations set in neurochemistry labs. And then I took another rotation in an electrophysiology laboratory, and I was hooked. I went into the laboratory of John Sarvey, who became my mentor at the Uniformed Services University, and he showed me the in vitro brain slice preparation, the fact that you could take a region of the brain. This is the region I'll be talking about today. It's called the hippocampus. And as you notice, it has a stereotype structure where all the cell bodies of a particular region are lined up in one layer, and all their dendrites point the same way, shown here. And you can slice this thin enough that you can place it into a recording chamber like this. You can perfuse it with something called artificial cerebrospinal fluid, which sounds fancy, but boils down to seawater plus some glucose and a bunch of oxygen bubbled through to keep the tissue alive. And you could keep it alive all day. And you could record electrical activity from this tissue all day. I'm reminded of one of my early physiology professors asking me in my first talk, so Mr. Stanton, how do you justify working on a dying preparation? And I could only say to him, well, I hope it's dying slowly, and I hope the control and the treatment preparation are dying at the same rate. But during a period of time before it does that, you can record synaptically evoked potentials from populations of neurons that you can study and activate with different patterns of stimulation. And you can study the effects of those patterns of stimulation on the strengths of the synaptic connections in this region. Shown here is a stimulating electrode and then a recording electrode in a brain slice from my laboratory. So around that time, well, a little before I got to graduate school, but it was still a very hot topic then, was the discovery of the phenomenon known as long-term potentiation of synaptic strength. Or as we jargony like to say, LTP. And I'll try to stay away from it, but if you hear me say LTP, that's what it is. And what Tim Bliss and Toivo Lomo and Anthony Gardner-Medwin discovered, both in brain slices and in whole animals implanted with electrodes, was that if you came along and gave a stimulus to produce a single evoked population excitatory postsynaptic potential of a sub-maximal strength, you could get a stable baseline, and then if you gave it a high-frequency stimulus called a tetanus, a burst, named so because like tetanus toxin, it releases a lot more transmitter, you would then get a sudden increase in the strength of that connection. And then if you went back to test the strength of this connection with the same stimulus intensity you had here, it would be larger. And the most extraordinary thing they discovered was it would be larger for the entire life of that preparation. And if it was a whole animal, it would remain elevated for weeks, even months. Arguably, the entire approach of this field of synaptic plasticity since then has been trying to test by as many ways as possible the hypothesis that this long-term potentiation is one of the things that occurs in our brains when we learn. And that the elevated strength of these connections, specific to the connections that are activated, not shared by connections that are not stimulated, is what stores the pattern we know of as a memory engram. The other thing that was happening very much at the time I was coming into graduate school was discovery of a particular subtype of glutamate receptors, glutamate being the major excitatory transmitter in the brain. This subset was the so-called N-methyl-D-aspartate or NMDA receptor. It's named so because NMDA is an exogenous chemical that selectively stimulates this receptor. And this receptor turned out to be essentially the exemplar of what Donald Hebb was talking about mechanistically. That is to say, this receptor at normal resting potentials when there's no neuronal activity going on or very little, has a channel that is blocked by the divalent cation magnesium. So nothing can pass through this channel. Seems pretty useless for a receptor, right? But it turns out that when you have a lot of glutamate released, as happens when you have a high frequency stimulation, or as happens when you have a learning experience, a learning trial, and you have bursts of firing of neurons, then this magnesium block, which is voltage dependent, senses the depolarization, the increase movement towards a positive potential in this postsynaptic cell. And that magnesium is kicked out of its binding site. then if and only if this synapse was part of the memory engram, then glutamate released at this synapse binds to its binding site and calcium rushes in through this channel. And it's that calcium that is a critical stimulator of calcium-dependent enzymes that cause changes locally in the dendritic spine. They cause changes in the cytoskeleton and the shape of the spine. They cause changes in insertion of other receptors for glutamate that make the response larger in amplitude. And they cause changes in gene expression all the way up in the nucleus of the cell that makes new proteins that are then shipped down to change and grow new connections in these neurons. So these NMDA receptors are absolutely central to our understanding of how learning leads to the kind of burst firing and activation that unblocks these NMDA receptors and activates them, and then leads to the persistent strengthening and growth of new connections. And I'll just say as a really critical aside that everything I'm talking about, as if it's relevant to adult learning, to what's going on in the room right now, is equally, if not more relevant to early development of the brain. The first time connections are forming, they activate these same mechanisms. And when they activate these mechanisms, they grow out connections that form and stabilize. And that's how our brains get formed in the beginning. So obviously, during these early critical periods of development, stimulation, experiences, activity, these are the key things that are necessary for the maximally optimized formation of these networks. Now, I was in John Sarvy's lab at the time, and I was interested in studying long-term potentiation, and I was studying the potential role of gene expression and synthesis of proteins in this long-term potentiation. And a colleague who, by the name of Joseph Moskal, who was across the street in the Nobel laureate Marshall Nirenberg's lab at NIH, came over to me and started a conversation that led to a lifelong collaboration. And that conversation was around the approach he was taking to try to find new cell surface molecules that might be critical for the formation of new connections between neurons. His approach was sort of a precursor in a way, logically, of things like the Human Genome Project and proteomics and a lot of other things. Because what he did was he took rodent brain tissue, rat brain tissue, and he homogenized it, and he immunized mice with the homogenate. And then using, at then, much newer methods for developing monoclonal antibodies. Monoclonal means an antibody that is one species and only recognizes one protein. He separated out a massive number of monoclonal antibodies and grew them up in cells, and then said to himself, now I undoubtedly have monoclonal antibodies that are going to recognize important molecules. How the hell do I find them in this huge group? And the answer was he started by screening the antibodies to see at least, do they specifically bind to and recognize neurons? Or do they just bind to anything? Well, that got the number down some, but then he came and talked to me and we decided, well, we need to eventually screen them for which ones might have physiological activity in affecting synaptic plasticity. And it certainly wasn't the first one we did. And I have always been impressed ever since with the reaction of my mentor when I went to him with the idea as well. And John very gently said, well, you can work on this some in your spare time and extra time, in addition to your thesis project. Don't be disappointed if it doesn't pan out right away or doesn't pan out at all, but give it a shot. And so we screened antibodies in groups, reminiscent of the way we now screen members of the community for COVID, when we take a sample from multiple people and screen it. And we eventually found an antibody called B6B21, which when we injected it into one focal region of a hippocampal slice and recorded from two sites, one neurons that had been received the antibody and one not, we found that when we induced long-term potentiation, the antibody-treated site had significantly larger LTP. We had no idea what the antibody was recognizing at this point, and the Nmda receptor was fairly new at this point. But we had a lead. Oh, and from that lead, we developed a series of potentially therapeutic compounds, small peptides that we screened for the ability of the antibody to recognize them because they were much more tractable to work with as potential therapeutics someday and to treat whole animals. And we came up with a number of these peptides, which we then screened again to see, well, which ones have the same properties B6B21. And that led to the discovery of what we called Glix 13. And Glix 13 was a fascinating, fascinating molecule. It's a proline, lysine, lysine, proline tetrapeptide, relatively simple. And it turned out that when you bath applied this drug to brain slices and you gave a submaximal high frequency stimulation, it enhanced the magnitude of the induction of long-term potentiation, just like the antibody did. So now we had a potentially more therapeutic molecule, which we still had to figure out how it worked. Right? So Joe had been doing a lot of binding studies showing that it bound to purified NMDA receptors, but reversibly and could be easily displaced. But a key experiment that we did together that now is done a number of years later was to show that if we looked at pharmacologically isolated currents, these are now postsynaptic currents into CA1 pyramidal neurons in this case, that these, if we pharmacologically blocked every other glutamate receptor we could block, blocked GABA receptors, that we could have a response that was only due to NMDA receptor activation. And at the end, we do a control to make sure it really is by blocking that. And what we found was Glix 13 at a relatively low concentration reversibly enhanced the magnitude of these NMDA currents. This and a lot of other data I don't have time to talk about tonight demonstrated to us that this drug indeed, this peptide indeed interacted with NMDA receptors in some way that promoted long-term synaptic plasticity. Now, I'm now going to move over a number of steps, but not too many steps, hopefully, and present you with something that I think is a concept that's very interesting about synaptic plasticity and about long-term potentiation and about NMDA receptors, which is, it turns out that the normal, as you might not be surprised from what I've told you, the normal functioning of long-term potentiation is critical to our ability to learn, our ability to form and recall memories. And it turns out there's a wide range of neuropsychiatric diseases which appear to have impairments in this plasticity and appear to have alterations in the expression of their NMDA receptors. One such is simply aging. I'm sad to tell all of us in this room, including me, that as we get older, the magnitude of the long-term potentiation and really the duration of it, how long it persists in our brains, reduces. It's not hopeless, it doesn't disappear, but as we age, this plasticity becomes impaired. And it turns out that Glix 13 can restore this plasticity to the levels seen in much younger animals, in very young animals and immature animals. So at this point, I'm looking at this experiment result thinking, sign me up. No, I guess I can't take the Glix 13 that's in the lab. That would be not permitted by all sorts of sensible regulations. And yet, it's very exciting to think that even things like normal aging could be treatable through these kinds of approaches to modulating receptor activity. But as might not surprise you, Alzheimer's disease, one of the quintessential diseases of impairments in memory mechanisms, and eventually in death of neurons, is also a disease that may benefit from the ability to upregulate, to restore, to rescue NMDA receptor dependent long-term potentiation. What's shown here is a little bit of a complicated two-set experiment, but what we've done basically is we've picked two separate inputs to the same population of neurons. The open circles are our control. The closed circles are the ones where we're going to inject beta amyloid 1 to 42, which is the small fragment peptide that is released in large quantities and accumulates in the brains of patients with Alzheimer's disease. It is far from the only set of molecular changes that occur, but it is one of them that occurs. And it turns out if you inject beta amyloid onto a population of synapses, and then you come along and you test how much long-term potentiation a submaximal stimulation produces, you find that the beta amyloid application reduces, impairs this long-term potentiation. So this would be a phenomenon very similar to the aging phenomenon we saw there, where you would want to restore this plasticity. And it turns out if you bath apply Glix 13 and you do the experiment, and now what I'm superimposing now is the beta amyloid applied site without Glix to the beta amyloid applied site with Glix. And what Glix 13 is able to do is restore, rescue this plasticity, thus suggesting that this drug or drugs like it could be useful candidates for at least the treatment of symptoms and early deficits associated with Alzheimer's disease. Whether it would slow disease progression is still at this point unknown. What about other diseases that seem to involve NMDA receptor function? This is one I would not have expected, but through my colleagues, including Joe Moskal and others who are by now at Northwestern University, and by now I was already at New York Medical College, they were looking at models of depression and post-traumatic stress disorder that involve the effects of chronic stress on the brain. And what they were finding is that, or what we found is that, if this is a submaximal long-term potentiation produced in a non-stressed rodent, a non-stressed rat, that if you stress animals chronically, and what do I mean by that? It's important that it's chronic and unpredictable. They get a different stressor every day for 21 days, which leads every graduate student in my lab to say, well, that's just graduate school. What are you talking about? But in this case, it's unpredictable. It is things like the animal spends an hour in a cold room, then on another day, he spends an hour in a warm, humid room. Then he spends some time in a cage on a shaker being bounced around. Then he spends the time in a box listening to a loud, annoying noise, and so on. But he has no control over that stress. And it turns out that that stress makes for a apparently very depressed rat. What do I mean by depressed rat? Well, there's something called the forced swim test, where you drop them in the water and you count how long they swim before they just give up and say, this is terrible, to hell with this, and they float. If they try harder, they're not depressed. If they're depressed, quote unquote, in this model, they give up sooner. And it turns out that Glix-13 administered systemically can restore these measures of depression in these depression models in animals. And Glix-13 can restore the magnitude of long-term potentiation, indeed enhance it above the baseline. So you can take a apparently depressed rat and you can make it undepressed through Glix-13. That is why one of the clinical trials that are going on now, or a set of them, involves the possibility that this might be a treatment for drug-resistant depression. One of the most fascinating things that we discovered was experiments where we looked at the chronic effects in animals of dosing them with these drugs, either individually or repeatedly over time. And what we found is actually the most amazing result, I think, which was if we looked 24 hours after dosing an animal with Glix-13, it's cleared the system by now. And then we prepare brain slices. We found that long-term potentiation was also enhanced in these animals. I have to tell you now, it's changed to Rapastanel. That's just a fancy commercial name that the drug companies have come up with. It's still Glix-13. This effect lasted 1 week and then is starting to come back down by 2 weeks post-dosing. If you give repeated dose, you can make this last for 4 weeks or longer. What is going on here? Well, what we called this was a phenomenon known as metaplasticity. The idea that by enhancing the induction of long-term changes in synaptic strength, like LTP, you could shift the threshold in favor of further strengthening of synapses and the ability to elicit more LTP. And so that metaplasticity gives the prospect of a treatment lasting much longer than the drug is present in your body, because the drug depends for its activity on ongoing thinking, ongoing synaptic activity, ongoing ideas, ongoing experiences. Now, another disease model that we've been studying in my laboratory for some time now, in collaboration with Lee Goldstein and Ann McKee at the Boston University Center for Traumatic Encephalopathy, is the effect of traumatic brain injury on the brain. We have a number of models we've used with them. One is a blast model, shown here with this blast tube, and a blast shock wave. Basically, you pump nitrogen gas in here until a membrane bursts, and then a shock wave comes down the tube, and the animal's head can move freely, and the shock wave makes the head move back and forth. And the result is an animal that has traumatic brain injury, has neurological symptoms that look like concussions, but then recovers. And it turns out, if you do behavioral measures of, can this animal learn and remember? The answer is that long-term memory is impaired. One such example here is called the Barnes maze, named after Carol Barnes, or it's a circular platform with 20 holes. 19 of the holes have little caps right underneath. One hole has a nice hidey box that the rodent can go and hide in. And there are very bright lights above this turntable. And rodents are more prey animals than predator animals. And so they don't really like to see this, that they get very anxious when they get this bright light. So that motivates them to find the place to hide. The first time you dump them on the table, they have no idea. They wander around at random trying to find the hole until they happen to stumble into it. But since there are visual cues around them on the wall, once they stumble into it, they learn where the hole is. So if you do more trials, you find that their mean latency to get to the hole goes down. That's a sign of learning. And it turns out if you take animals that were exposed many weeks previously to a blast wave and their head was free to move, their learning is impaired. They eventually get there, but they have impairments in their ability to learn this particular learning task and others that I can't talk about tonight. But for us, if you're buying into my lifelong interest in long-term potentiation and in plasticity, is the question of, well, are there long-term effects on LTP that correlate with these behavioral effects? The answer is yes. So that if you are an animal is exposed to a single blast wave and you look either 2 weeks or 4 weeks post blast wave experience, the animal is walking around as if it apparently looks normal, but it has impaired, reduced magnitude of long-term potentiation. And this has led to the development of a pursuit of clinical trials to see if effects of traumatic brain injury might possibly be treatable with a drug like Glix-13, like Repastinel. Now, I've lost a sense of exactly where I am on time, but what I'd like to talk about here is I'll move forward now to some experimental results that we've acquired much more recently that are due to be published within the next month or so in the journal Neuro Report as the cover article. And what we've done here is try to identify the mechanism by which Repastinel and drugs like these work on the Nmda receptor. And so this is a modeling 3D schematic of the Nmda receptor, which has a large extracellular structure, has a pore through which calcium can go, and has an intracellular C-terminus. One thing you need to know I haven't told you yet is this intracellular C-terminus is an important regulator of how Nmda receptors function. It's essentially a governor, like the cruise control on your car, so that once calcium flows into the cell through this channel, remember it's activated by glutamate, right, by activity. Once it flows in, it binds to an all-purpose protein modulator of effects of calcium called calmodulin, and the calcium-calmodulin complex binds to the intracellular C-terminus and suppresses the NMDA current. So the NMDA channel has its own governor. If it gets activated some, it shuts itself down and isn't activated more. Turns out, we did an experiment using 2 different kinds of calcium chelators, one or the other, in the intracellular solution that we infuse into the cell. One is a slow chelator called EGTA. The other is a kinetically much more rapid chelator called BAPTA. And what we found was a very intriguing difference in the two. EGTA will also bind calcium. So in a sense, you have it in the cell. It's competing for calcium, competing with calmodulin for calcium. But calmodulin's affinity is so high that it loses the competition. And so you can still have this suppression of current, this inactivation. It's called calcium inactivation when you activate NMDA receptors. Now, if you apply Repastinel, you add it in the bathing media, you find the current gets bigger. And you find that it gets bigger because this inactivation is relieved. This inactivation by calcium calmodulin is reduced. So here is a fascinating long distance effect of the extracellular binding of a molecule to change its conformation in a way that alters the intracellular performance, the intracellular function of the C-terminus, and relieves this inactivation. So now the NMDA receptor current gets bigger. And this panel shows you that if you just put EGTA in, nothing happens to the current. So EGTA is not an effective competitor for calcium calmodulin in doing its inactivation. Look in contrast to this experiment. If you put BAPTA in, which actually has a very similar affinity for calcium to EGTA, but it has a 40 to 500-fold more rapid kinetic. So right close to the pore, it is now able to compete for at least some period of time kinetically with calmodulin for the binding of calcium. So the first thing that happens is if you put BAPTA into the pipette and you let it infuse into the cell, you watch the current get bigger. So you're invoking NMDA current with pulses of glutamate or stimulation. In this case, it's electrical stimulation artifact. You get the current getting larger and larger until it plateaus at a new enhanced level. So we interpret that to mean the removal of this calcium inactivation. And most importantly, now when you put on Repastinel, it doesn't do anything anymore. The effect of Repastinel is occluded by the fact that BAPT is in the postsynaptic intracellular environment. So this leads us to the hypothesis we're now putting forward that this kind of long distance regulation of the receptor and potentially other receptors by ligands that bind outside the cell could have very important effects on the intracellular regulation of the function of receptor channel complexes, leading to the glutamate being released, being able to activate them in different ways. This is important because it's important to remember that this therapeutic, like the EGTA, this therapeutic doesn't do much of anything by itself. But at those synapses that are activated when you're learning, when you're forming a new memory, those are the synapses that are going to have enhanced activation of Nmda receptors and enhanced induction of long-term plasticity, both long-term potentiation and one I haven't had a chance to mention today called long-term depression. Synapses can go up and down, but that enhanced plasticity is what is changing the connection patterns in ways that represent the memory engrams. So this is to the point of clinical trials. I hope soon to the point of clinical trials for more neuropsychiatric diseases where it might potentially be advantageous. But this is the winding path over 30 plus years to get from a fascinating experiment to discover an unknown macromolecule using the power of antibodies, which can recognize macromolecules very, very well, to an actual treatment that can help people. And it's mirrored by my transition from a kid as a scientist wanting to understand how the brain works for very basic, in the intrigue of science means, to realizing that this is the understanding, this is the kind of basic research done in academic institutions like New York Medical College that will drive the eventual development of treatments, drugs, and other treatments that can tremendously help benefit people's lives and their quality of life. So with that, I was actually having a lot of fun. I have no idea how long I went, which is unusual for me. I'm usually right on time. The most important slides are the next three. And yes, there are three at this point. There's usually one, right? I need first to acknowledge my mentors and my collaborators. This is a partial list of collaborators, but my mentors, John Sarvey, graduate school at Uniformed Services University, and Uwe Heinemann. I was at the Max Planck Institute in München when I was with him, but he went on to the Humboldt University, the Charité, and Terry Sinofsky at Johns Hopkins for my second postdoc. This is John Sarvey. This is Uwe Heinemann. They are both sadly gone now, and I miss them tremendously. But they were huge contributors to my development as a scientist, my development as a mentor, and my development as a person. The collaborator partial list includes collaborators at New York Medical College. And then I'm very sort of embarrassed to realize it doesn't include Jerry Nadler, who's now one of my collaborators as well. Sorry about that. But includes a list of some of the immense number of people who I've collaborated with at institutions that I've been at and throughout the world that have been instrumental. Science is not done alone. Somebody in their first talk says we stand on the shoulders of giants. We stand on the shoulders of people who are standing on our shoulders. We're working together in the same teams. We're working together to make ourselves all better than the sum of the parts and to advance science in that brick by brick way that we construct the house of science while we continually try to punch out the bricks and replace them with better bricks. Most important is to acknowledge the people in my laboratory over the years. I stuck with just New York Medical College and the people who have been trainees in my lab, colleagues in my lab, friends and mentors to me as well, people I've mentored in the lab. Most importantly, I must mention Dr. Shali Zhang, who's been in my lab my entire time at New York Medical College and who's a senior research associate, and who's really the guts of the laboratory and really a lot of the brains of the laboratory. And we, go through everything, go through ideas together, take part in meetings with all of our other colleagues, and he's a co-equal participant in everything we do. But everybody else who comes through and trains in the lab are co-equals as well, students who have gone on to continuing growth in their careers in science, in some cases in education, I have graduate students and postdocs who I've trained in my earlier time at Albert Einstein College of Medicine, who are now faculty members, tenured faculty members, in one case a chair. I couldn't possibly be prouder of them, and I couldn't possibly thank them too much for all they've contributed to me and my joy of and experience of science. In the last slide, I'll just quickly go through a few pictures and point out that this is John Sullivan, Chirag Upreti, Chen-Yu Cho. John is an MD PhD, Chirag's a PhD who went on to Eric Kandel's lab. This is Omid Miri, Galadou Suba, who's on the wards now, so he won't take my calls anymore because they work much harder on the wards. Katisha Gopal, Linnea Vos, Mohammed Irfan. This is Shali over here. That's Alexander Mogadim, who is at Duke in a research residency at Duke. And currently in my lab, Callie Hollander, who's a graduate student doing her thesis project in my laboratory now. This is Shali again. And Yolanda Shen, who's doing a rotation in my lab, who, and I hope, but don't tell her yet, but I hope will join my lab, will opt for my lab. Finally, and most importantly, I have to give the highest thanks to my love, my life partner, and the one who has always supported me and always encouraged me and always shared in everything we've done together. And that's Susan Ilan, who's here tonight with us. And that's her underneath the, the text feed there. And also very importantly, my twin 5-year-old granddaughters, Olivia and Sasha, who I hope will one day be the next students rotating through my laboratory as high school students and beyond, if they're interested in doing science, and I can contribute to them carrying on the next generation of scientists beyond. Because that's the thing that New York Medical College taught me more than anything else, is the tremendous joy and power of a true academic scholarly pursuit of research, investigation, education, service to the college. I thank Dr. Ludmar again for the opportunity to serve on the Anti-Racism and Anti-Bias Committee as well, one of the most extraordinary experiences that I would have not otherwise expected to be on in my life. Most importantly, learning that, remembering and growing in the joy of mentoring the next generations of scientists. With that, I will close with a final thank you for this extraordinary award and honor, and for the extraordinary opportunity to share all of these honors with such an extraordinary group of friends and colleagues. Thank you.
Thank you, Dr. Stanton. And thank you all very much for joining us this evening. And thank you for participants who may still be online. This concludes tonight's event, and please safe getting home. Good night, everyone.